Alright, good morning. Welcome back from break. We're just going to jump right back into math. I know last week we kind of did some review, test corrections. Make sure you did your test corrections. I'm missing a few, I think from Nathan and John. Maybe you put them away and you didn't turn them in again. But make sure those test corrections are done. So if you get finished early with today's assignment, that's something that would be great to work on. And if not, then you know you got more free time. But what we're getting into now is a little bit of geometry. So I'm not sure if you've covered this before. You're probably sighing already if you have. But hopefully this will be a quick review. Or if not, then it's some new material. So give me that feedback. So we're going to be looking at measuring angles today. So what I have here is something from your math reference book. Just do a little bit of instruction before we dive into the problems, and we're just going to classify a few different angles. So the first thing to note right here is that an angle is made up either by two rays. So my pen, there we go. Right here we've got two rays. So the ray means that it's not a line, because a line goes in two directions for infinity. So a ray goes from one point, normally we do 1 point, outward. So here, right here, is our point of our starting point. They call it the vertex. And you see the lines go, or the ray goes outward. So it's only going in one direction in infinity. So we've got two sides. We've got A and we've got C. And so our angle is formed between, measuring the distance between those two sides. How far off are they going? Because they're going to go in infinity, and it's the same angle for infinity. That angle doesn't change. So angles are formed by two rays or by two line segments. See here, our lines, they stop. It starts at B and it ends here, and we'll call it C. So it stops. See, our whole line right here goes for infinity, but these are line segments. So again, that's just how what we call our angles. Scrolling down. So the thing that we use is this thing called a protractor. And we're calling it a half circle protractor because, you see in this picture, it's a half circle. It's not a full circle. A full circle is 360 degrees, just like if you were to spin all the way around, like in skateboarding, that's a 360. But our protractor only goes to 180. And so this is the tool that we use to measure, and you'll be given each your own protractor here to use at school, and one for home for doing homework. So as you can see with some of these pictures, I'm looking right here, some of these pictures are showing us these measurements. So the measurement of A, angle A, is 60 degrees, and that's measuring this red part inside. But we can also measure the outside of an angle, and that's what B is looking at right here. Here, we would say this is our inside because we've got our Pac-Man eating something. But we're measuring the outside. So the outside of that angle is really 225 degrees. And the same thing with C. But mostly what we're concerned with today is measuring the inside angle, like A. Unless it asks you to measure the outside, or maybe find the outside angle. But we need that inside angle. It's really important because we can't actually use a protractor. If you see here, our protractor only goes to 180. You can't measure something greater than 180. So for finding B, the outside, you'd probably find this inside angle and then subtract that from 360. Sometimes you might be doing that. We got a few different angles going on here at the very bottom, and this is something that you will be doing, is classifying angles. So we have 5 main angles. First one is our right angle. A right angle is always 90 degrees, and they typically always show a right angle with this red box right here. Typically right angles always have that red box to show that it is a perfect square angle. Second one, acute. An acute angle measures less than 90 degrees. So it cannot be 90 degrees. It has to be less than. It has to be greater than 0. Obviously, you can't have less than 0. But it must be between 0 and 90 degrees. Acute. Obtuse is the opposite. That's greater than 90 degrees, and it's between 180. So it's between 90 degrees and 180 degrees. That would be obtuse. And for a straight angle is pretty much just a straight line. It measures exactly 180 degrees. So we have here a line going in left to right for infinity. And our last one, when we're measuring that outside angle, it's called a reflex. So a reflex is anything greater than 180 degrees, going all the way up to 360 degrees. Okay, so just some important language to remember. Pretty much the three main ones are your right angle, your acute angle, and your obtuse. Those are kind of the main ones that you'll see in all the problems upcoming. Sometimes you'll deal with the straight angle and with the reflex, but most of the time it's just these three. Okay. So let's look at how to use that protractor, and we'll do some examples, and then you can go off on your own. Keep coming down. Okay, so here we've got an example of how to measure an angle with a protractor. So I'll make it a little bit more defined. Right here is the angle that we're trying to find. So we have P, Q, R. And those are the points. So we have line P, we've got line R, or ray, excuse me, line P and line R, and they start from Q. So what you want to do is you want to put the center of your protractor, there's a little hole right here in the middle, you want to put that exactly on that vertex point. So right where Q is, that's exactly where you want to put it. You don't want to use this edge, you want to use right in the middle. And you want to line that up, and pretty much you just kind of look at where your lines line up. So you always want to make sure that this is, how do we want to say, parallel to the ground, that it's completely flat to get the accurate reading. So you want to make sure that your bottom line is lined up with your 180 degree line or your 0 degree line. And then there you measure, you look to see where this line intersects. Most of the time it should be pretty exact. Your protractor should have the exact number. Sometimes you might have to estimate though. And you got to guess. Maybe you got to add 2 or take away 2. But you just got to do your best answer. So we can tell right here that this angle is acute, so I'm going to write A, because it is less than 180 degrees. So it's kind of grainy, but the top number, you see here we've got 100, here you got 110, 120, so this would be 130. Now do you think 130 is our correct answer? No, that's not, because we can see this is acute. And remember, acute angles are less than 90 degrees. So you know it's not that number, so it's got to be the other number, which would be 50 degrees. So we would say that then this angle, like right here, the measure of angle PQR is 50 degrees. So that can be tricky sometimes. Make sure that you are using the right number. So it would be incorrect if you said that this angle was 130 degrees. That would be incorrect. Okay, now let's take a look at some questions and kind of, I'll show you what I would do, and then you can go ahead and start. So here's what it looks like in your math book. We're gonna, the classifying angles, this is something that you can do, but let's take a look at number 6. So I've got my printout of a protractor right here, but as you can see it kind of won't be perfect, but it can work. So it says, use your full circle protractor. Ooh, we do not have a full circle, so just use your normal protractor right here. And remember, I've got to line it up, so this isn't going to work the best, but it'll give you an idea. So I want to be using the center point I want to use it right where Q is. So I'm going to try my best to kind of line it up. Something like that. And I got to rotate a little bit, something like this. So this is generally how you want to align it. Remember, it won't work if you keep it flat. That's not going to give you an accurate number. You always want to line up one of your lines with your 180 line. So let me go back to our marker. So you always want to make sure that you center it around this point and one of your lines is touching this 180 line. Okay? So that's why you always got to change your protractor to do that. So you would simply just move your protractor around, and since yours is clear and mine's just a picture over a picture, you'll get a better reading other than I can. So if I were going to put this, let's see, I still got to change it a little bit. Something like that. So I'm just going to guess that if I were to have a line going like this, and then we'd say this one's going kind of straight up from this angle. So it's kind of like that. I would venture to say that this angle, the correct answer, would be, I don't think I got mine exactly lined up right. Let's try this again. So we're on 180. And there we go. So I think that's pretty close, and that is going over the 60 number and the 120. Which one's our right answer? Acute angle, so 60. So for number 6, our answer would be 60 degrees. We're doing this one right here. Don't worry about, don't do the outside angle, just worry about the inside angles. So all the questions that have to do with find the outside, use a full circle, skip those and just always find the inside angle, whatever it can munch on. That's what we'll worry about today. Okay, raise your hand if you have a question. Please don't continue on if you don't understand. You need to ask for help. And since I'm teaching multiple math classes, you got to tell me. Can't always do it after the fact. So raise your hand if you need help. Thanks, and I'll see you in class.